Hi everyone. So today we are going to do the last lesson, believe it or not, for the Bootstrap World coding unit, which means after today's lesson, if you are completely up to date with everything and everything has worked out for you so far, you will actually be able to play your video game today and receive points and have the collisions work and see all of your hard work so far come to fruition. Okay, so you will need your WeScheme video game file. So I would get that open, logged in, ready to go so that when we get to that point, you're all set. Okay, so by now you have defined a function called distance. We just did that in lesson 9 the other day. And the 4 inputs that we used for the distance function were inputs that were numbers that represented the player's x and y coordinates, and we called those px and cx, or py, excuse me. And then another character's x and y coordinates, and those were the c values, so cx and cy. Okay, when we calculated the distance between 2 points on a graph, we used the Pythagorean theorem. Right? A squared plus b squared equals c squared. When the computer calculates the distance between 2 points, the computer used the distance formula. Okay, but the thing with this is both of these are essentially the same thing. So the Pythagorean theorem and the distance formula are essentially the same thing. Okay, so in this box here, we just have an example that we're going to recap from lesson 9, and it's talking about finding the line length of the distance between 2 points. So in example 1 here, it says if the player is located at the coordinates 320, 240, and the danger is located at the coordinate 400, 160, the distance can be calculated by evaluating distance 320, 240, 400, 160. Now the computer, when we enter that code, is actually going to compute all of this. So it's going to do the distance formula. Remember, square root of the sum of the squares of two differences. So the first thing is my x values. So if we look at these, my x values are 400 and 320. We got 400, 320. And then the second thing is the difference of the y values. So since we started with 400, we have to start with 160 and then 240. Okay, so take a second and see if you can fill in example 2 and example 3. It's the exact same thing. Okay, so for example 2, if the player is located at 0, 100 and the danger is at 500, 250, the distance can be calculated by evaluating the distance of 0, 100, 500, 250, which means the code it's actually evaluating is going to be line length 500, 0, line length 250, 100. You want to keep your order the same. And then for the last one, you should have 50, negative 10, 100, 380. So my line lengths would be 150, and then 380, and negative 10. Okay? So now that you know how to compute the distance between two objects, you need to decide when two objects have collided. So we discussed in lesson 9 that if your characters are two circles, then the two circles will overlap or collide when the distance between their centers is less than the sum of their radii. So as a general rule, 50 pixels is usually a sufficient distance for detecting collisions between your player in danger or your player and target. So number 3 here says, what code would allow the computer to check whether the distance between the points 300 and 240 and 400, 160 is less than 50? So the key here is less than. That's our function. So when we write the code, this is going to be the less than function. So we need to figure out, is our distance between those two coordinates, so 320, 240, 400, 160, is that distance less than 50? That's what we're trying to figure out. Okay? So we want to complete the following design recipe for the collide function. So we are going to write a function called collide, which takes 4 inputs, and they're the same 4 inputs that the distance function did. So this again is going to be 4 numbers, just like the last one was. Okay, so the name of my function is called collide. Excuse my clock in the background dinging. So my inputs are 4 numbers. Number, 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 number. Okay, and then when we do this, it's going to give me something that's evaluating a less than thing. So when we think about less than, greater than, equal to expressions, if I asked you, is 2 less than 7, you would tell me yes or no, right? You wouldn't say 7 or 12 or 3, or I wouldn't get a circle. So this is our new type of data, the most recent type of data we've talked about, and that's a Boolean. It's going to say true or false. Yes, this value is less than 50, or no, it's greater than 50. And there goes the Christmas clock. See? Such a great time of year, guys. Our purpose statement here. This function decides whether the characters are within 50 pixels of each other, right? Because we're trying to figure out if these things are colliding or not. So decides whether or not the characters are within 50 pixels of each other. Okay, if they are, that means it's going to give you true and they would actually be colliding. So we have our examples here, and the first one is done for us. It says example, collide 100, 200, 300, 400 is figuring out if the distance between those coordinates is less than 50. So for our second example, collide 150, 350, 600, 500, we want to figure out if the distance is less than 50, right? And then my numbers inside here are in the exact same order as they are in the collide function. So this would be 150, 350, 600, 500. Okay? So if we think about the way that these are in the collide function, these first 2 values are the values of our player. So that would be px and py. The second 2 values are those for the other characters. So that would be cx and cy. So in our definition, the player coordinates come first, and then the second character comes next. So that would be cx, cy. Okay, and then we're trying to figure out if it's less than 50. We have px, py, cx, cy. Okay, so just like with the last few lessons, the collide code I have already typed out for you, and there is a Word document in today's Schoology folder for you to download. So if you download the Word document, you will end up with this piece of code. And just like we've been doing, you are going to copy this code into your video game file. So it's right under what we did in lesson 9. So if you scroll down to the collisions section again, if we go underneath what we did in lesson 9, you will see the collide px py part here. That is what we want to get rid of. So we're going to delete that out. And I want to copy the code that is provided. So we're going to copy this and we are going to paste it in our video game file. Okay, so what should happen now if you click run is you can actually successfully play your video game. Meaning if you run into your danger, you're going to lose points or potentially lose the game. And if you run into your target, you will gain points. So what should happen, the way the game is set up, is you should score 20 points when you collide with your target, and you will lose 50 points when you collide with your danger. Okay? So I'm going to run this and play my game. So you see I just collected the star and I ran into the alien. So you can see at the top my score. I want to lose for you guys so you can see. So every time you run into your danger, you should get that silver star. Then you got to keep in mind, you have to, the center of your player has to hit. So you see every time I run into the danger, my score goes down 50 points. So now it's at 30. Now I've lost the game because I lost 50 points, which made me go under 0. Okay? So at this point, you want to just send me a screenshot, record a little video on your phone showing me you playing your game, and I will give you credit for the final checkpoint. Okay? I hope you all have a great day, and if anyone has any questions, please feel free to reach out.